Alright, if you guys are labeling this circle, and we kind of already been doing some of this stuff. This is the center right here. And this whole thing right here is your diameter. Whoops. I know how to spell diameter. D-I-A-M-E-T-E-R. Okay, oh, I skipped radius. And then radius is this. But you could also say this is radius. Because as long as it's from the center and it goes all the way to the circle, that's a radius. So we got center, radius, diameter, central angle. The central angle is any angle that is that has its center at the center of the circle. What? Like this guy right here. That's a central angle. But this right here is also called a central angle, and this right here is also called a central angle. All these are central angles. If it's in the center of the circle, it's a central angle. So I'm going to label this one right here. Let's say central angle. It kind of looks like an angle. That looks like an angle. So all these are called central angles. I should probably double one that one, and this one I'll put 2 tick marks on it. Okay. And then finally, the sector of a circle. I'm going to highlight the sector of a circle. Let's see. I'll highlight that. The sector of a circle is this. It's all that. Okay, that is a sector. All right. So let's get on with the show here. A blank is the region bounded by the arc of a circle and 2 radii. The sector, a sector, A sector is a region bounded by the an arc and of the circle and 2 radii. Rewrite the definition in your own words. Go ahead. So for real world examples, we get the obvious: the pizza, the pie, the cake. Very good, guys. The sector of a circle can be described as a fraction of the circle. So you can write down that. A fraction. Alright, I mean, you say fraction or part or piece, like a piece of pizza, of the circle. I mean, you could have said that if you were trying to write it in your own words that you understand. The fraction of a circle is the part divided by the whole. Another way to say it, okay, the ratio of the area of a sector to the area of a circle, you can write it like this: area of sector divided by the area of the circle. I've seen it done another way too. The central angle is on top, and 360 degrees is on bottom. And this last one right here is what we're going to use the most. Central angle divided by 360, because 360 is the total of the circle. Okay, let's try one problem right now. Okay, so wait, there's one more thing we have to write. What does it say? The area of a sector of a circle is the product of the ratio. Oh yeah, we just wrote that. We'll say central angle divided by 360. And the area of the circle. Okay, so it says product. That means we're going to be multiplying. All right, so let's try it. Find the area of ZOM, which is zome. When you guys read the sector, ZOM, you start with Z, and you go to O, then you go to M, and then you finish connecting it. Okay, it should have at least 3 points. Actually, only 3 points, I think, for sectors. Leave your answer in terms of pi. I love it when it says that. When it says leave it in terms of pi, we don't have to multiply the pi out. So let's see what we get. The first thing we need to do is we need to find the area of the circle. Actually, you can do this one first, but I like finding the area of the circle first. Let's find the area of the circle. How do you guys find the area of a circle? Do you guys remember that? Go ahead, tell me.
Pi r squared.
Yeah, it's pi r squared. Area of a circle is pi r squared. What's our radius for this one?
20.
It's 20. Okay, so I'm going to put 20 right here. We have pi 20 squared. 20 squared is 400, so we have 400 pi. It said leave in terms of pi, so I'm not going to multiply 400 times pi. So that's my area of this circle. But I only want the area of the sector. Okay, so we have to find the fraction that sector is related to. And to do that, we're just going to take the central angle, which is 72, and put it over 360. Now you can simplify it right now, right off the bat, or you can just use that big one and multiply it times the area. So let's just use the big one. Okay, 72 over 360, and I'm gonna multiply that times 400 pi. Okay, whenever you multiply a fraction to a non-fraction, we like to make the non-fraction into a fraction. So let's make that non-fraction into a fraction. And cross-cancel. We can cross-cancel stuff. You guys remember cross-canceling? That's when you look at the numbers that are opposite of each other, and you try to see if you can divide each of those by the same number. So look at these ones. This one and this one, you should see a number that you can divide them both by right away. Oh yeah, 4, yeah. 10, but why would I want to choose 10 over 4? Yeah, well, 10 is bigger, right? So then if I divide this one by 10, it loses a 0. If I divide this one by 10, it loses the 0. Ooh, that's nice. So now I have 40 and 36. Now you want to do the 4? Yeah, let's do the 4 now. If I divide that one by 4, I get 10. If I divide that one by 4, I get 9. Is there any other simplifying that I can do? Non-opposite each other. I can't simplify those. I can't do anything simplify that. Okay, but now check the numbers on top of each other too. If you can divide the top and the bottom by the same number, that's simplifying. Can you do that with 9 and 72? What can I divide 9 and 72 by? I can't divide 9 by 8.
72 by 8.
I would divide both of these by 9, and I would get 8. So you're technically right. Your brain's kind of doing what I do. It's like the dyslexia kind of thing, where you're trying to ask a question, but you get... Okay, never mind. Okay, so we have the 8 times 10 pi. That's what's left over. Oh, cool. We did this all in our head right here. No calculators needed. So 80 pi is the area of this sector. Shaded in. Look at that cool highlighter action. Alright, let's go on to the next one. Now, the main difference between this one and the last one that we did is this one doesn't have a picture for us, and this one says round your answer to the nearest tenth instead of leaving terms of pi. So, let's draw a circle first. Here's my circle. It has a diameter, a better circle. Okay, that's kind of better. It has a diameter of 20. That's cool. What is the area of a sector with a central angle of 280? Or, sorry, that's not 280, that's 208. Well, let's get rid of this diameter because he's kind of in my way. I know the diameter is 20. Okay, I'll circle it so I don't forget. Okay, diameter is 20. I need a sector that measures 280. This is 208. I keep saying 280. So this whole angle right here is 208. That's a big old sector. Here, I'll highlight it too so you guys see what I'm talking about. Okay, this is the sector we're going to find the area of. The first thing we need to do is we need to find the area of the whole circle. So, we need the radius. You guys know what the radius is? Diameter is 20. What's the radius? Yes. Okay, so the area of the circle is going to be 10 squared times pi. And I'm not going to multiply pi out yet. I know it says round. I'm not going to multiply pi out yet. I'm going to multiply pi out at the end. That way my answer is most exact. The most exact. So this is my area of the circle. Now I need the fraction. What's my fraction for this one? What's the central angle for this sector? 208 over 360. There's your fraction, your ratio. So we have 208 over 360, and we're going to multiply that times the 100 pi, the area. Okay, so I put 100 pi over 1, and then I check to see if I can do some cross-canceling action again. Those zeros, gone again. Divide them both by 10, now I have 10 and 36. Okay, what would you guys like to do next?
2.
The 2? Okay, so this is going to be 5, and this is going to be 8, right? 18. Alright, can I do anything else? Here, I'll clean it up for you guys. We have 208 over 18, and then we have times, that's 5 pi over 1. Okay, now I see I can divide both of these by. I can simplify that fraction. What can I divide those both by?
Maybe
4?
4. Maybe,
No, a 4 doesn't go into 18. 2? Okay, let's see. That's 9, and that one is 104. Alright, cool. So now we multiply straight across. This is what we get. We have 104 times 5 times pi. And then on the bottom we have 9. Alright guys, plug this in your calculator. Go 104 times 5 times pi, and use the pi button. Don't use 3.14, because the directions didn't say to use 3.14. If the directions said to, then you would. and then divide it by 9 and round to the nearest tenth. What'd you get?
570.
570?
Yeah.
Okay, we're gonna double check that. Correction, it's 181.1.
I did pi first.
Ah, okay, and that's do we have units? Yeah, we have units, centimeters squared. All right, next example we'll save for the next video.